Hi guys, Mr. Wilson here again, and now we're going to take a look at vectors. Now, this topic, quite often there's an easy 1 mark, but then the next marks are quite challenging. So let's see how we get on. I always like to start with this because this is a real life example of how people can easily understand vectors. Now, if you've ever been sailing, if the wind is coming in this direction, and here's the finish, you can't simply go that way unless you're under like a motor. So if it's a sail, you have to use the wind and what we call tacking to travel in a forward direction. So you would have to tack like this to get there. So basically you're heading in this direction and then this direction to get there. And we call this our resultant vector. Now normally we label our vectors not with numbers. We can write a vector like numbers, like you should know from translations to describe movement. We use vectors. But in this, to try and make it easier, we just label them something like A and this one B. So we can say the resultant of doing both of those vectors is simply A plus a B. Okay, so this is another just a basic exercise to get you to understand it. So we've got two vectors, this vector here A, which we know is this length and in this direction, and a vector B. And we've got the question, what is the vector from P to L? So it's like giving directions, and these would be the streets. You can't just say walk through the buildings until you get there. You have to talk in terms of directions. So you might say to get from there to there, you can go along an A, along another A, so it's two A's, and then up a B. So this would be two A's plus a B. G to P, from here to here, this is slightly different. So we're going that way. You notice now the arrow is in the opposite direction. So when we're going against this arrow, we call this minus A. And because there's three of those, 1, 2, 3 of exactly the same size, that's minus 3 A's. And then again we're going against the arrow for two of those, so it's minus 2 B's. And then you just put them together, so minus 3A, minus 2 B's. So here is the first instance of when it starts to get a little bit harder. So this is the information you've got. We're also told that O to A is A to P, therefore this and this must be the same, so therefore they're both vector A. We're told that B to Q, so from here to here, is 3 of those. So if that's vector B and it's on the same line, there's 3 of them. So what we say is this vector is the same as this one, but it's got a different magnitude. It's 3 times bigger. And we're told that N, this point here, is the midpoint of this line. Now, and here are our questions. So A to P, the first one, dead easy, that's A. A to B, so you can see the first bit we're going against the A, so that's a minus an A plus a B. But quite often mathematicians like to start with the positive term, so we always write B minus an A, but both of those are perfectly correct. O to Q, pretty sensible, pretty easy, I meant, 4 B's. And P to O, again, nice easy one, that's minus 2 A's. Okay, so P to Q is a classic first question, so you can't simply go from there to there because the vectors aren't there. It's like sailing into the wind on the earlier example. You can't do it, you have to tack in a different direction. So to get from P to Q, using the vectors we have to go from P to O and then O to Q. So that is going minus 2 A's and then 4 B's. So minus 2A and a positive 4B. And once again, we can swap those around the other way because it looks a bit more mathematical. Now P to N is a little bit harder. This is where it gets a bit trickier because you can't follow the vectors to get there. But because we know the vector from P to Q, P to N is simply half that distance because it's the midpoint. So if we know what these are, we can simply half it, and there you go, to get to P to N, or again, the other way. So 4 B's halved is 2 B's, 2 A's halved is 1 A. Now O to N, we're going to be using this one, and obviously we're going to go up to P first. So I'm saying O to N, and look how I'm writing this. This is a really good habit. So O to N is O to P, and then P to N. I'm telling the examiner my journey. O to P, it's 2 A's, easy. P to N, we've just worked it out. Collect the like terms, you'll see that 2A and a minus A can be collected, giving us 1A and 2 B's. I haven't said this yet, but you must always put your squiggles underneath your vectors to show it's a vector and not just a normal letter from basic algebra. Okay, so that's up there. And if we look at a to n, it's pretty much exactly the same, but instead of starting from O, we're going from a to p and then p to n. So it's an a and then p to n again. The a's will actually cancel each other out this time, and we'll be left with two b's. And that's it. That's vectors. So let's have a look at a slightly trickier one. So they're like hexagons, and because it's regular, they're testing your ability. Do you know that that vector would also be there? Because it's exactly the same length line in exactly the same direction, so it has to be the same vector. And therefore, this is the same, and therefore we can do the same with the b's and here. Now, these are where it gets tricky, because a lot of people say, well, that's the same length as a b, so that's minus b or something like that, but it's a completely different direction. So a vector describes movement in a certain direction. So let's have a look at some questions. A to C. We can't get from there to there, but we can go along the vectors that we have. So that's a plus a b. Let's have a look at this one. C to D. So from there to there, we haven't got a vector, but we can do this. We can go minus a and then a b. So minus a plus a b. A to D. So that's quite straightforward. There's two of those, so it's two b's. B to D. Now, that's where we've got to go, and you can do this in quite a few different ways. So this is the one I've chosen to do. So it's a B, but then you can see there's another B here. So I'm going to say that's two B's, and we're going against the A. So I've actually made an error on this video. That should be a minus A plus 2B. So I do apologise, but because I'm telling you, I expect you not to make that mistake. Now, sometimes they do this. They give you extra information. So they say B to M is 2B. And then first of all, you look at it and go, there isn't an M. And that's because they're telling you it's two B's. So from B, if you do two of these vectors, you will get to M. So there's two B's from there. So 1B, 2 B's, that means M is here. And F to N, from here to N, is 2 A's and then minus 2 B's. There's 2 A's, minus 2 B's, and therefore it is there. So what do you know about the points M, C, B, N? So they are on a straight line, but you actually have to prove it these days. So what I'm going to say is, well, C to B is negative B. And if you do M to N, you can see that's minus 3 B's. So like I've said these words already in this video, but this is the vector, the B. This is minus 1B, and this is minus 3 B's. So this is just 3 times bigger. So it's the same vector, just 3 times bigger, and therefore it means we're going in exactly the same direction. Therefore it's parallel, or if they're on top of each other like this, it means they're a straight line. Now, this is when it really gets tough. So they start introducing ratio. So point C splits it into 2 parts and 1 part. And we've got here O to E is double that, so this is also a midpoint, and we're told this is a midpoint. So O to C, that's B. Well, what I should have said is B is all of this. So they would normally give you a bit more clarity. So it looks like that could be B, but because it's 2 parts and 1 part, that's 3 parts in total. This is 2/3 of that journey, so therefore 2/3 of B. O to D, so we've got the whole B there, and then we've got this bit, and we haven't got a vector from there. But if you think, how can I create this? You've got to look at all of this. So O to D is O to B, which is simply B, but this is where it gets tough. So I'm going to do this over here. So B to A, we can do as this: minus a B, come down to O, and then along to A. So that is the vector to get to this destination. But B to D is therefore going to be half of that vector, so it's just half everything. So here we go, that's half. So all I did there, I swapped it round because I prefer to write the positives first. So swapped it round, halved it, and just added it in. Tidy up, so we've got a B, take away half a B, so we're going to get half a B and half an A. Either way round, it doesn't matter. So please remember, if you're stuck, if there isn't a vector to get there, just think it's half of that vector, so that's what you have to do. C to O, again, this one's quite easy because we've done O to C, so it's just minus 2/3 of B. And I'm not going to show you any more because this is a revision. You have to check out my normal videos on YouTube to see some more. But that should be enough to help you on your way.